Welcome to this episode of the NewSpace India podcast, a bi-weekly talk show that exclusively talks about India's space activities. There are thousands of talented engineers and scientists who are groomed in ISRO every year. And my guest today is one of those engineers who went on to pick up an entrepreneurial dream, a dream to build a team that can independently build and operate a privately owned launch vehicle out of India. Pawan Kumar is the CEO of a Hyderabad-based rocket startup Skyroot Aerospace. He and Bharath, who was his former colleague at the Vikram Sarabhai Space Center, started Skyroot Aerospace to independently pursue building a small satellite launch vehicle as a private company out of India. Pawan, thank you very much for spending time with me on a Saturday at your office, and welcome to this episode of the NewSpace India podcast.
Thanks a lot, Narayan Prasad. Pleasure to be here.
Not many people 10 years ago would have imagined that we will actually see a private launch vehicle startup in India. And, you have taken this brave step of going ahead and developing your own launch vehicle. Tell us a little bit about your history and how you got into launch vehicles. And how you gained the experience through your ISRO days.
Okay, so first thing is that I graduated from IIT Kharagpur in mechanical engineering with my master's in thermal science and engineering. So where I worked a lot in the cryogenic engineering center at IIT Kharagpur. So that was like first introduction to, and one of my projects was in space, cryo cooler in space, right, for spacecraft. So that is my first introduction to space, and like I've always been excited with rockets especially, and I wanted to get into this industry. And luckily, ISRO came to campus placements. And then I just wanted to get into ISRO. Then luckily I got placed in ISRO directly from out of campus and then joined ISRO. Then before that I had absolutely no idea about, I was fascinated with the rockets, but I have no idea what is the technology inside. But after joining ISRO, that was like the first great introduction to rockets. And initially I was in the division where which handles most of the hardware. So I used to see big hardwares in our bay getting integrated and moving, transported. And then I was on the launch pad with the launch operations. Looking at the big rockets there, I was very fascinated and got in depth to the, even the design aspects of it and a lot of testing aspects of it. So the broad view in 6 years I had at ISRO. Also out of my own interest and curiosity, I also used to study architectures of, foreign launch vehicles, as part of it. And so it was a great time. And during that time, my interest kept going exponentially in rockets.
So when you talk about your experience inside of ISRO, outside of ISRO in academic world in India, you actually have not many people working on launch vehicles. So when you say you got an introduction to rockets in ISRO, it literally means that everything that you know about rockets came from working at ISRO.
Yeah, totally. Yes. So what if you see in university side, I think it's a little bit more preliminary at this point of time, because one thing is that there's not so great partnership into the core engineering between academia and ISRO, to be frank. So that way what happens is that academics is a little bit void of the real engineering aspect of rockets, especially in launch vehicles in India. So that way I feel if you want to actually have a really good exposure, it's only within ISRO. Outside is a little bit preliminary, we can do small testing, etc. But when it comes to the core engineering part, it's still within ISRO only.
You are then in ISRO for 6 years now and was there serving. Why did you think that you would become an entrepreneur?
Yeah, so firstly, my mind was I always wanted to be an entrepreneur for a very long time, from the college days itself, So, but I was very hardcore. I consider myself a very hardcore engineer, and I wanted to be an engineer. And also I also wanted to be an entrepreneur, right? So first I thought let me join ISRO, and I wanted to become a core engineer, and let's see what happens. But that entrepreneurial mind which I had from the beginning in the college days itself, that kept on being there during the ISRO time also. Because naturally my mind was looking for opportunities in space sector, and also looking at the really good things which are happening internationally, and also the debate internal to ISRO also to privatize a lot of space industry and all, right? So I thought this is the right time to step out and start a company. And I'm also a strong believer that space is the next big thing, and also I'm also fascinated with the future in space. I personally believe that humanity is going to expand to space in this generation, my generation, the next 50 years. So that all together inspired me to come out of ISRO and start a company.
So when you were in ISRO, you must have interacted with a lot of ISRO vendors who actually supply to the launch vehicle program.
Yeah.
What do you think, or how did you position yourself in your mind as against to these traditional vendors?
Yeah. So as I told, like ISRO culture is very much ISRO vendors. Their culture is really, really good because of their interaction with ISRO for long periods of time, for the last few decades. So that way, what I've seen is that even now, like we interact with a lot of vendors. So what we see is that the vendors who have been supplying for quite some time to ISRO, they're very well cultured. They have a really good knack for quality of aerospace systems, and they're really, really good at what they do. And all that I should say, thanks to ISRO because of building up such a culture within them. And it's really, really good to go and meet them. Is almost like ISRO's facilities, more like ISRO's internal facilities. And if you go to vendors' facilities or some of these really good vendors, it's almost same. So that kind of a culture has been brought in. And that's really good to interact with them because it's almost similar to the way people think in ISRO is what comes there, and that comes because of the interaction with ISRO.
And when you talk to these vendors, or why did you think they did not have the risk-taking mindset? Because for about 30 or 40 years, a lot of the ISRO vendors have been working with the launch vehicle program.
Yes.
And how come, even big brand names like Godrej, who supply engines and so, they have not really gone to the next level of just, moving away from just a subsystem to then an entire launch vehicle?
Yeah. So firstly, thing is that I think they did not get that opportunity of being a system level player. And mostly ISRO wanted to have them as subcontractors, individually manufacturing parts or assemblies. But engineering aspect to it, testing and other aspects of it, they're not involved at all. So ISRO did not involve them at all. So that is one of the reasons why they have not ventured into. And another thing is that design engineering and manufacturing are totally different subjects. The person who might be absolutely good in manufacturing stuff, designing and engineering of the same subsystem is different ballgame altogether. So it's totally different stuff. So it's together bringing, only unless ISRO encourages them to do it, it's very difficult for them to take it up also. So that is, I think that's the main reason why these vendors could not actually get into those aspects of it, because ISRO did not encourage them many aspects of it. But now it's coming up. Maybe now they are going to get into the subsystem level. Supplying of subsystem levels would come up soon, is what I feel. Yeah.
So when you started your company Skyroot, what were the strength, weaknesses, opportunities and threats that you saw in the whole scene?
Yeah. So when we started out, first thing is we were very clear on what to be done in the next 1 year when we started. So that way we are spot on to the work from day one. So one challenge was finding the right people. Luckily now we feel that we have got the right set of people, and another big challenge was interacting with the vendors, creating the proper supply chain. And to convince many of the vendors, to convince them that actually it is possible in long term to actually build an entire launch vehicle altogether, so that they are also very cooperative. So these have been the main challenges. And also now what we feel is one of the main challenges which we feel is fundraise is one major challenge which we face, because the investment community in India is a little bit nascent for space. Just now they are getting introduced to space and all. So that is the main challenges I felt in the last 1 year.
Okay, but what about, let's say, more than just challenges? What were the opportunities that you saw? Because essentially you were in the public sector, and the landscape of the private sector and also the exposure to the international community is quite limited if you are, still a very young engineer in ISRO. But did you have any, connect with the international community? How were you following all of these developments?
Yeah. So first thing is that mostly through news only. All the international development happens through what we observe only through news. And when it comes to, especially through rocketry, so everything, as I mentioned, everything can be made in India, everything can be designed, outsourced, everything can be built within India itself. So per se, for rocketry, interaction with international international players, and with that may not be required. So that is one thing. And another thing is that opportunities, in sense, like we are very clear on the business model. What we do is actually we build rockets and do international satellite launch services. So our product is very clear. So we are more focused on the tech and building the product right in the right stages, getting things tested and get them working in the right time frame. That's the main focus which we are at, and we also will be in that in the next few years also.
When you had a plan to exit ISRO, how long did you plan for it? Did you have a plan in mind that maybe you will quit at certain point of time and you have this kind of roadmap, or?
Yeah, so it happened very quickly. In fact, like I was planning to stay ISRO for a very long time initially. So then somehow I felt that if we don't start now, it's lost opportunity forever. So that kept bothering me for quite some time, for a few months. And then when I actually looked at the market scenario deeply and also looked at opportunities which I would get in the next 10 to 20 years, and also when I looked into the need of public-private partnership in India's space program in the next 20 years, I felt this is the right time, we should start it, and then took a call. It took maybe a couple of weeks to actually digest the fact that I want to quit, and also forever. I cannot go back to ISRO again. So then only I took a call that I want, after weighing all the benefits and everything, then only I came out.
And of course, you cannot build a launch vehicle alone, and you have to have a team together. How did you find your co-founder, and how did you build up your team?
So firstly, my co-founder Bharath he's been one of my best friends, and we joined in ISRO together, and in fact he was my flatmate for quite some time. During his entire time at ISRO, he was my flatmate. So I know him very well, and we have very good sync, and he's also very good at what he does, and he's from the electronics background, and we gel together very well. And so he has good exposure to launch vehicle electronics also. So me being a mechanical engineer, he being an electronics engineer, we felt it's the right combination to start with, and we also having a really good relationship with each other. We thought we have to pair up for this. And when I pitched it to him, he was very happy to explore the opportunity, and when he explored the opportunity, he felt this is the right time to start, and then we clubbed together and we started this.
And what about finding talent outside of ISRO realm?
So one thing is that finding talent was slightly easier because I had really good contacts outside through ISRO contacts, and outside contacts also were really good. So there were people who actually recommended few other people, for example, when it comes to aerodynamics or something, the people who our ISRO friends have worked with before. These people have come from outside industries in India. So through that, I've interviewed them, and some of the best cream from them we have recruited. And in fact, we got 15 people on day one. So we really consider ourselves very good at recruitment. Identifying the right talent, the right time, sharing the vision, bring them on board is one really good skill set with the Skyroot founding team. And we, as of now, it's really going very well.
Let's talk about actually the market mechanics within India and abroad. So there are, I think, about 170 or 180 launch vehicle startups as of today around the world. So there may be hardly less than a dozen of them really operational, or maybe 2 or 3 of them really operational in that sense. So how do you see this market playing out, given that there are so many people doing so many different things? And what gives you the advantage of being in India and doing this?
So firstly, there's only one operation player in this small satellite, that is Rocket Lab. And there's a couple more operational players coming up from China, both of them from China. And that happened last 6 months only. And so when it comes to the large number of, these all are announcements actually. So according to my understanding of the market and my understanding of the technology, I think in the next 5 years, maybe 10 players would actually make it to launch. Among these small satellite micro launchers, maybe 10, maximum 15 is what I feel in the next 5 years would be actually going to launch. So our focus mostly is on who is going to be in the top 10, 15. And that's what there's really good companies like Vector and Firefly Aerospace and Relativity Space from US, and PLD Space in Europe, and Orbex from Europe, from UK, and one company in Australia. And these are the only companies which we look into as the real ones who are actually going to get to launch in the next 5 years, right? So I really believe this 170, 180 is just one of the pseudo numbers, because more of announcements than actually, if you see, most of them are not even seed funded, and also funding really plays a major role in this. And if you see a company in US or in Europe, they need minimum $80 million to go to the first launch. So $80 million into 170, just count. It's impossible for anybody to get this much funding in a limited market, right? So it's like natural to see that only for 10 to 15 players only would actually make it in the next 15 years, in the next 5 years. And so we're only looking at these people as a competition, because that is actually the real competition. Someone who actually tested their hardware and ready to launch in the next 1-2 years is the actual main competition which come in the picture. And among us, what we feel is that we are in the right category to actually get to launch in the next 2 years. And also always the first companies in a country are always advantageous than the fifth or sixth company from a different country. So that is one advantage which we have, being one of the first companies in India to do it. So there is very high chance of success for the first couple of companies in any country, and rather than after that it really gets difficult. And also the technology which we are choosing, and also the vendors which we are choosing, or the direction which we have chosen, we saw that we wanted to get to launch as quickly as possible and start operation, because that is the key most point in getting to market early in this high competition zone. So that we are doing pretty fairly well as of now to actually get in the right direction. So that way, and also I feel the competition as also if the launch opportunities increase, even the satellite players also increase. It's a slightly related thing altogether. And as I told, there's definitely not room for more than 10 to 15 players. And in my opinion, even more than 10 to 15 players may not make it to the first launch. So we want to be in the first few players to make it to the first launch. And I think looking at how it goes, we are fairly confident that we'll be in that zone.
So one of the interesting aspects of the whole space trade with respect to the launch vehicle business is that there is a lot of red tape, artificial red tape created because of government policies around the world. So when you look at US, for example, ISRO is given actually a waiver by the US state and the Commerce Department to fly satellites from US, because ISRO is not a signatory for the commercial launch services agreement. So there is some of these artificial barriers that are in place for you to be allowed to fly some of these satellites for other players. Do you think your business will be affected because of this?
So these are very preliminary to say as of now, because we really don't know until we start launching and all. But still, these issues will be there, may or not come. And bigger threat which we face would be red tape within India rather than red tape outside India. So within India, red tape should be actually should be solved first. That is the first point to actually get to start launching. Then the other problems come, international trade problems, like what you're saying, US allowing to launch or not, because the US also will have a good number of players at that point of time, So, but I believe that also, if PSLV is able to launch is only because US industry is not able to meet the entire demand. Because if you see 50% of the satellite demand is from US, and it's very difficult for even the first 4 players to actually meet the demand. Even if the first off-floor micro launchers come into operation, still they might be doing 4 to 6 launches for the next 3-4 years, because even if you see Rocket Lab started launching in 2017, now it's 2019, still they're doing 6 launches a year. So it's very difficult to ramp up production. So even if multiple people come in together, they may not actually meet the entire demand for the next 3-4 years. So I feel that this US allowing other companies to launch may not be so effective for next few years. But bigger problem, as I told, is red tape within India, which needs to be solved to actually go and become operational.
So for you to be actually operational, you of course need to then test out your stages and the technology and on the ground, and then be allowed to use a launch pad and to fly. How do you think all of this will come into play in the next few years? Because I don't think there are set rules for anybody in the private sector to actually do some of this level stuff.
So that is one wrong assumption. Basically, there are all these rocket propellants come under explosives, and explosives is a very clear law in India. And so for any testing, or there are clear rules and all, and we have identified sources to getting things done. So that way, testing is not an issue. But when it comes to launch pad, That's all. Currently, all launch pads are owned by ISRO, and all the launch ports are owned by ISRO or other government agencies. So that is how it is going to play. Is only like time will tell, because like we're in contact with both of them to ask for launch pads or either space in their launch ports, etc. So how that will turn up is also dependent on policies. How the policy, how fast they're going to allow, and how open they're going to be, and how open these government agencies would be. So there's a different dynamics which goes to play in getting the launch pad. But when it comes to testing, it's all clear.
How does it work internationally for players in the private sector who actually use government launch pads? Is this based on leasing per launch, or they just take over the launch pad, or how does it actually work?
Yeah, so I think it's leasing the launch pads. They'll lease it for a period of time with this thing, and that way, and also their rules are a little bit open. Their rules say that you can lease it to private companies, kind of a thing. So it's all worked out. All the rules are worked out there. But when it comes to India, it's not at just preliminary. It's just coming up. We really don't know. And we being the first players, right? We will face the actual all the paperwork kind of a thing in the initial phases. We'll see how it comes out in India. But in US, it's more of leasing the launch pad from government. It's been quite open for quite some time.
So, in ideal scenario, because ISRO itself has very little launch pads, 2 or 3 now operational launch pads. Do you think that it probably makes sense that, let's say, you are willing to put up your own launch pad, that you would just be given space inside Sriharikota because they already have a set launching a station, at least, as in facilities where you can track and use that facilities for mission control and so on. But only thing is, maybe you have a dedicated private sector operated launch pad, which is independent of the ISRO launch pads.
Yes. So in fact, that's what we are looking at. We don't want to use the original ISRO's. It's not good to use the original ISRO's launch pads because it's very, very difficult to, because they're already using it and it's built for their purposes. It's not at all good to disturb these launch pads. And also we being one of the first players, accident could cause damage of it, which will also prolong, it will also delay other governmental activities, which is not the right way to do. But being small launchers, actually the launch pad infrastructure required is very less, very small. So we could build it ourselves. So what would be required is land from the government. So that whether they'll allow it or not is the open debate right now, which we are anyway in contact with them. And it's also all related to policy. So once the policy opens up for private sector to launch and everybody is clear, then I think it should be open to them to actually lease a particular land, and then also use the radar facilities, the tracking facilities which they have, which are already present there at ISRO. That should be the ideal way to do. Otherwise, because building an alternate launch pad some other location and taking land, large amount of land, and then building the tracking systems, that all not at all feasible for a private company. So investment in that time is not at all feasible. So we are expecting one of the 2 government pads in India would actually allow us to launch from there.
What about all the ancillary activities that go along with the launch? Because essentially, with the launch, you have to then, file a NOTAM and get a Coast Guard to clear all your, the path, especially launching out of India. And you also have, let's say, the insurance, for example, in case the pad is actually damaged or so on. So these are things that are taken care of within the government system, within, by ISRO and all the bodies. How do you imagine doing
So basically, around the world, right, if you want to launch, you need a launch license. Right? So who gives the launch license is a question. Right? For in US, FAA gives the launch license. In India, who gives the launch license? Not yet known. Right? So once someone gives a launch license, all this will be covered in that. Has to be covered in that because the Coast Guard, even that airspace has to be cleared, where the stages are falling has to be known. Right? This is a very standard process, and that will be taken care by the licensing authority who actually gives the license for launch. So once that is clear, it will be part of the licensing procedure.
So when you talk to the investors, your investors, were they asking these questions to you? Because these are uncertainties for any investor.
So basically, it is uncertainty for anybody, even for us, not only investors, even for us also it's uncertainty because it is the first time someone is doing in India and attempting it and all that stuff. So that way, and we know that it's a known risk, So, and also it's more of a chicken and egg problem where until we actually build it and prove it, nobody's going to take it seriously to actually provide facilities and providing licensing arrangements for it. And without doing anything, nobody again will create those procedures, right? So it's like a chicken and egg problem, both are related. So parallelly it goes. And also if you see, in all the countries other than US, it is happening the same way. Even in New Zealand, in fact, the first launch in New Zealand happened before the space law came there, by taking local permissions, by having a good understanding with the government, etc., etc. Same thing, even China also doesn't have a space law. They are allowed to launch, right? So it's all like parallel activity where like these licensing arrangements and this development happens together, right? So that is one thing which everybody needs to understand. So we understand it, and also like we help our investors also to understand it. That's a parallel process. It's not like somebody gives you a license, then you raise money. So it's not going to be feasible that way. It's a parallel process, and it should be seen in that way. Yeah.
How do you see the landscape in China evolve against India?
Yeah, so Chinese are like way ahead. In fact, the first Chinese companies, all these companies have started in 2015. So that is like almost 3.5 years ahead of the Indian companies, if you see. And they have, one good thing is that that time there were like little bit less players internationally also. So, and also like good amount of investment interest within China. And that way, like they were able to raise very early on very large amount of funds. So that way, there's a very advantageous position. Most of them are already tested, and 2 companies have already flown, did the first launches. So that's a really good thing that they have started in the right time, and also like raised capital at the right time. And that way, they're a little bit ahead of India, what I would say. But when it comes to like the technology prowess and the capabilities or speed, etc., I don't think India is anything lower than China, because like we have a similar rocketry ecosystem for the last 50 years. So that way, like with technology power and capability power will almost similar, I would say, when it comes to private sector. But when it comes to like the fundraise, interest, and the time, they're a little bit ahead.
Yeah, one of the interesting aspects of the Chinese launch vehicles companies that are coming up, as well as the Indian ones, like including yourself, is actually if the local demand for the satellites will actually be allowed to be absorbed by the private sector. Because I'm sure that like last year China did the most number of launches, and they beat the US with 39 launches. And one of the aspects of this is maybe if Chinese want to do low Earth orbiting satellite networks, they can also use the private sector vendors to come up. And even in the case of India, ISRO does not have any LEO satellites constellation for communications or anything planned. But maybe ahead in the future they may plan for it. So do you see a future where you are actually launching satellites for ISRO?
So that is, launching satellites for ISRO is a little bit far to think right now at this point of time. So our customer base, what we see is like only international, nothing within India. So it's very nascent. Satellite industry within India is slightly nascent compared to other countries. And also like when it comes to China, you might be knowing like Chinese companies cannot launch any payload with US payloads. So that like makes them off the 50% of the market. Right. And one advantage they have good amount of local market, which is actually distributed even with government and private. And there's like good amount of aggressively built rockets made by government. Like there's a company called X-Space, which itself has raised like many hundreds of millions of dollars itself. It's like Antrix equivalent of China, you can say. Itself has raised private money. It's a totally different ecosystem there. So there, I think they have a good amount of local market, which is distributed to both government and private industries. And also being large number of players, it's also diluted. It gets diluted with each player, etc., etc. And also like not being able to launch US payloads also reduces their amount of market. But in India, like because as of now, like there's no restriction of launching US payloads. It opens up to 50% of international market there itself. But there's no local government, so it basically compensates for the total market availability, but for both India and China is what I feel. Because there they have a local market, but there's not much access of the international market. Here we have like no local market, but there's good access to international market.
Let's say you are successful in having a technology demonstration of a rocket and you're able to get to the orbit. What would be your core value propositions which are unique, which you can sell to the market? Because today, let's say an Electron is already 2 or 3 years into the market already and have an established supply chain of payloads that they're going to put up into orbit.
So one thing is that biggest proposition would be like a good amount of cost benefit which we would give, and second thing is that we're also planning to have some very niche services, so which I cannot share, but some niche services which would serve niche customers, some special customers, which these are the two things, mainly cost benefit and also some niche applications which we're going to serve, which other people may not be able to serve. So these are the two advantages which we value propositions which we put. And also we have from the beginning we're developing a launch vehicle set which is upgradable. That means if you see, we call it Vikram series. Rather than one single launch vehicle, it's a series of launch vehicles where mostly it is same, 80% launch vehicle is same, but the 20% keeps changing. So when the 20% keeps changing, and we chose that the 20% will be in such a way that significant effect in the payload is there and significant reduction cost is there at each stage. Right? So as we evolve, as we go ahead, what will happen, the prices will keep coming down significantly. Not not because of mass production prices coming down, it's because of the upgradation of the launch vehicle where the prices are coming down. Right? So we feel that as we go further, our launch vehicles will become more and more competitive. And one thing, and also from the beginning itself, the cost will be low. We can operate at a much lower cost than any other foreign vehicles. That is one advantage. And also we are actually designing a launch vehicle to serve few niche applications, which probably we'll announce down the line as we go further. But that way we want to have something differentiated, both the cost and also cost will be prolonged. That means even for the next few years, cost will keep going down. And also we'll have some capabilities of serving niche customers. Yeah.
So one thing that I forgot to ask you in this process is, so what is actually Skyroot looking to build?
Yeah.
And what are the brief, broad overview of the technology specs?
Okay. So what we're looking to build is we're looking to build small launchers. That means launch vehicles capable to put around 300 kgs to low Earth orbit. So mostly we'll be looking at constellations of satellites, customers who are building constellations for the satellites who want different inclinations, and technology wise we'll be building, designing, testing and launching by ourselves. Entire operating we'll be doing it ourselves, and then we'll be serving the international customers down the line, and also if domestic customers need be at that point of time. Yeah.
And you have a plan to upgrade some of these launch vehicles to bigger class?
Yes. Not bigger class. The same launch vehicle will be actually upgraded to different payload capabilities. So we can serve something 200 to 700 kgs. A very wide band of payloads which we can serve. And also cost also will be reduced depending on, the bigger the launch vehicle, naturally the cost per kg is going down. So that way it actually covers a wide band of customers within the small satellite launch sector. That's what we do.
And with respect to the whole, again back to the investment scene in India.
Yeah.
So you have a bunch of investors now, and they're mostly seed stage investors, and you have some milestone where you're looking to raise significant Series A to do certain things, or how does it work now?
Yeah. So basically we raised seed round almost a year and a half ago. And now we are actively raising a next round of investment, which will actually take us to next big immediate milestone of almost testing all the hardware and all. Right. So that is going on, and and further that also there will be a lot of funding requirement even when we go to launch operation and all. So it's a continuous process of raising money and raising capital and also testing hardware. So it's a continuous process, and now we're in the phase of raising the next round of funding.
What do you think launch vehicle, given the cost advantage in India, a launch vehicle startup like yourself or any other launch vehicle startup, how would you say is the financing requirements for anybody out there to actually go from initially from the drawing table to the launch?
So that is actually one of the main advantages for us. In fact, we can go to the launch at 1/3 the cost a typical US or a Europe startup would take. That is the biggest core advantage for investors. They need to put 1/3 the money to actually go and operate in the same markets. So that's clear-cut value addition, which we get, where the developmental cost, which is called the developmental cost, that the cost which is incurred to go to the first launch is extremely low when compared to any other foreign player. So that is a short value proposition for any investor.
Do you see any competition coming out of India itself for you, or no?
So there is another company, Agnikul, also working in that similar range, in the similar field. They're also building their own launch vehicles. Yeah, and also might come, maybe more companies may come up in the future. Yeah.
Do you see any of your own ISRO colleagues starting their own companies?
It's maybe unlikely in launch sector because it's already getting crowded. So now if new companies start, I don't think there's much room. So it's like always, as I told, like it's always the first 10-15 players who can make it to orbit, and the late they are now. I think in 2019, if you start a launch company, it's really not the good time to start. But still, like there is like other different very exciting space ventures which we could go into, and also like we also looking to diversify into, which could be a focal point. But launch per se is like we ourselves feel a little bit behind the line when it comes to international starting, because many companies have started and done reasonable progress internationally. So again in India, starting now is a little bit much going backwards. So I say especially when it comes to launch sector, but there is like ample opportunity in space as a whole. So I look forward to see like really good people, maybe even from ISRO, starting good companies out there in space in the future.
Let us actually compare a little bit of technologies within the landscape of launch vehicles internationally.
Yeah.
There are, from my understanding, I'm not a launch vehicle expert, but from my understanding of all the launch vehicle startups, there are broadly 3-4 different themes maybe.
Yeah.
One is somebody like an ISRO SSLV, which is straight off, just off the shelf, legacy technology, scaling down a PSLV and trying to build a launch vehicle for mass production without actually developing anything new in terms of technology.
Yeah.
There's another group of people, let's say like an Electron, who's experimented with some 3D printed whatever engines or liquid fueling of rockets, completely so that they can have more safer operations on a launch pad or so on.
Yeah.
And then there is now the more flashy new generation kind of launch vehicle startups like Relativity Space, who are talking about 3D printing an entire rocket. I don't know if that is even really possible at all in that sense. So how do you see, does this really impact the price at the end? Because ultimately the customer doesn't care what technology you use. He just needs to get to orbit safe.
Yes. So when it comes to technology per se in rockets, everything is a legacy technology. So there's absolutely nothing totally new which anybody is doing. But when it comes to manufacturing, there is like Relativity Space is wanting to 3D print the entire rocket is like a little bit very, very interesting, which I also look forward to see them very successful. And that is one, I would say, one good leap when it comes to building smaller rockets, I would say. But other than that, like when it comes to propulsion tech, it's all both liquid, cryo, or solid. It's all legacy tech, right? It's all there from I don't know how many years, last few decades. It's just about engineering them in the right way. And so that is one thing. And eventually when it comes to the customer, it's only about like at what cost you're actually launching and at what reliability it's all launching. It's always like with any of these kind of propulsion tech or different kind of manufacturing techniques, you can actually achieve the same amount of reliability and cost and all, like if you actually target the engineering in the right way. That is one thing. And when it comes to like 3D printing of engines, is like it's been like for quite some time. It's not such a really new thing. But when it comes to the 3D printing, the entire rocket is little bit interesting when it comes to it. And in fact, we are also doing a lot of 3D printing ourselves because it has like natural advantage when it comes to conventional manufacturing in some specific things in rocketry, which we are very clear on. And also like even if ISRO is also slowly getting into it. So that way, like 3D printing has become like part and parcel of rocket industry right now. But 3D printing the tanks, like what Relativity Space is doing, is a little bit very interesting to see how it goes. I look forward to see how they do it, and I'll be happy if they'll be succeeding. And that way, they're building actually a scalable 3D printing technology by themselves, which is very, very interesting. Spending a lot of time on actually building the tech for 3D printing is very, very interesting. And once they do it, I think it can cut the cost to a good amount of extent for them, because but still, like I have my own doubts on some aspects of it. But look forward to see how things go with Relativity.
But what about the prices? Do they substantially make a difference depending on the...
Yeah, so prices, actually there are two major aspects of prices differentiation. One thing is the ecosystem in which the rocket is built. Like the ecosystem in sense, like for example, the country in which the rocket is built has a very good direct proportionality with cost. Number one. And when it comes to technology also, like the propulsion technology use also impacts the cost. So these two reasons mainly impact the cost. And if you see, when it comes to propulsion technology, it might be, maybe plus or minus 30% would be the cost range. And also like when it comes to ecosystem on which the rocket is built, like the country you're building it and the materials you're using it, it is also like plus or minus 20-30% would add to it overall. So not much. So finally at the customer point of view, they would be maybe looking at 30-40% maximum difference in pricing.
ISRO, of course, also came out with its own proposal for a small satellite launch vehicle maybe a couple of years ago.
Yeah.
And they are already claiming that they will do a first launch at the end of this year or maybe beginning of next year.
Yeah.
How do you see that evolving, given that you are also in a very similar business now?
Yeah, so that will be, as you asked before, like who would be the major competition for us? Like we feel that SSLV would be a good amount of major competition for us, and that too because like already most of the development is going on, and they might launch next year, and also like their pricing also would be really good, is what I suppose, because being a much bigger rocket. So, for example, their rocket size is like maybe like more than 4 times of what we are building. Naturally, the cost per kg will be less. And also like they'll have, because there is no extra policy red tape associated with that term, so they can smoothly get into operations fast. And also they have like good amount of customers through Antrix also previously come into picture. So SSLV I think will do a good job initially for the first few years, but depending on how the international competition turns out in the next few years, the dynamics will be different. But SSLV I think would right now would do a good job in the next few years.
So let's assume the worst case scenario actually, that let's say, you have the technology ready because that is under your control, and you have some investors who are also backing you because they believe in your vision and so on.
Yeah.
And let's say the whole system in India, the bureaucracy is actually not ready for somebody like you to actually, test and, fly your first rocket.
Yeah.
What is the contingency plans you have?
See, I strongly am very positive that it's going to, we want to actually do it from India, and also like start launching from India and open up the sector in India, help at least open up the sector in India, which I am very positive it will happen. And of course there is a contingency plans also, and also like it's more of a long-term vision for Skyroot. It's not like next 2-3 years is not what we are looking at. We're looking at next 10-20 years. It's always a long-term view which we have. One big major stepping stone now is get to launch, and that to launch from India. So that is what we are looking at. And of course we'll have a contingency plan, because like we need to actually test a lot of stuff ourselves, and that we'll see as time goes. We'll see how it rolls out. But I am very positive that things will open up very positively in the next few years.
Well, what is your view of reusability, and is reusability only making sense for bigger class of launch vehicles like SpaceX, or do they actually also make sense for smaller vehicles?
Yeah. So like my belief is like, at least from my understanding of rocket, because I myself have personally looked deeper into this problem from a long time, even during my time at ISRO. My conclusion is that like when it comes to like bigger rockets, is definitely reusability is the future. There's no doubt about it. When it comes to smaller rockets, whether it is reusability is worth the time, worth the effort, worth the developmental cost, worth the trials, worth the going, because it's definitely going to increase the time to launch, time to get into the market. So is it worth? But I feel it's not worth getting into reusability for smaller rockets. And it's better for smaller rockets, better be like mass manufacturable very fast, using the right technology, and go to market as soon as possible are the main factors which come into picture. And I feel reusability is in fact it's tougher for smaller vehicles than larger vehicles. Even if you want to achieve reusability for smaller vehicles, it's extraordinarily tough when compared to achieving reusability in bigger vehicles. Because like if you see all the reusable technologies, for example, landing of rockets, very difficult to land a small booster when compared to landing a big booster because of the inertia differences. So that way, reusability per se, I feel like for smaller, always expendable. That means one-shot rockets are the best. So they'll be slightly costlier, but still they're the best. And when it comes to bigger rockets, the reusability is undoubtedly the future.
One of the key questions in the whole private sector launch vehicle scene around the world is actually state support to private sector. If you look at many other geographies, including US or even Europe, you have, NASA or any other US government agencies, or even in the European case, you have the European Space Agency or, the European Commission funding a lot of research in many of the private companies there.
Yeah.
And they have this significant benefit of operating in that geography.
Yeah.
I know that this ecosystem does not exist in India at this point of time.
Yes.
How affected are you by this? Does this really, is it a real challenge that you face?
Yeah. So in fact, when it comes to Indian companies, biggest challenge we face is the funding. No doubt what form it is, whether it is like institutional investments or whether it is through grants. So good thing is that Europe, more than institutional investments, the grant policies are really good, and that's the advantage. In fact, many of the good developing companies there in our sector, they have had a good amount of funding coming from the government. So that helps initially for them. It's good. But when it comes to India, like that is very, very nascent. And in fact, like when we also pitch to the people in the government about a fund, it's like totally even they are also very new to it, very nascent to this idea. So hopefully it will come up, but it's too late for launch sector to come up, much later down the line. So it's now we are anyway off the side. So we have to, for Indian companies, we mostly need to have institutional investors support or like another different kind of investment support. When it comes to grants in India, like we are very well behind, and also the thought process not started in the government sector is what my understanding is with my interactions with them. So, but whether it will come in the future, it's good. Like we have to try to always convince and create a fund of funds for space. Like countries like Europe is having, China is having, and Japan is having. US institutional investors are like also like very fascinated with space. So that investment culture in India, whether it's through grants and both institutional, is right now is a little bit nascent. And let's see how it will turn out. And but like you said, in Europe, that is really, really good. The grant culture for startups for space is really, really good. And but thing is that there also I feel there is a lack of institutional investor support compared to what is in the US. So that way in India, all type of investment sources are slightly less, and also like red tape is also more at this point of time. And so we are actually operating in a very, very challenging and risky environment. But still, that is where still India has really good advantages. So there's basically good value add which Indian companies can bring to the global space community is what we feel. So we should keep looking for great opportunities coming up both from government side, from the institutional investor side from India, and look forward to see how things happen down the line. Yeah.
What is the roadmap for Skyroot to, test your first rocket, as well as what is the kind of volume that you are expecting? How many rockets do you expect to fly?
Yeah. So first major milestone would be actually making it to orbit. So making it to orbit is the toughest and one of the most difficult things in space industry. If you see like recently one of the interviews of Elon Musk also, like he was saying that reaching orbit is extremely, extremely difficult because like SpaceX itself has missed the first 3 attempts to reach the orbit. So on these notes, first big milestone for us to reach orbit. Then when it comes to mass producing and increasing the launch range is easier problem to handle down the line, because like that is addressed from the design and engineering part of actually building the architecture of the rocket itself. So we are designing it to be mass producible in very large amount of times, doing as many launches as possible. But reaching the orbit, seeing that everything perfectly works until the payload is put into orbit is the toughest challenge, which we have to address in the next few years in the design quality philosophy which we follow. That we are very, very cautious on that thing, and that is a major challenge, and we'll see how it goes. And also first launch, definitely a lot of government support is required. Absolutely, it's very difficult for a private industry to independently without the government support to actually do. So we look forward to have good support from the launch range point of view, and also range safety point of view from these government agencies.
You have a deadline in mind as to when?
Yeah, so we want to launch in 2021, third or fourth quarter. Or maybe early.
In 2016, actually, interestingly, I had an opportunity to go to SpaceX. They had invited me for some meetings there, and I actually had almost an entire day at their facilities, also looking at their production facilities, as well as the entire tour of their the whole process, starting of components and then engines and then actually integrating the whole rocket on one single floor.
Yeah.
I don't think there is any other company or any other institution in the world that is actually producing rockets on a single floor in just one facility.
Yes.
And one of the challenges actually they mentioned to me interestingly was supply chain itself. Yes. Because essentially the supply chain that they were working with at that point of time was of course the one from NASA.
Yeah.
And NASA doesn't build so many rockets so the vendors were actually not geared up to producing that or scaling up volume to that level as they needed. Yeah. And so they were actually forced to actually in many cases in-house produce those components and actually move away from working with those vendors to actually taking that back into their own shop floor and producing everything there.
Yes.
What do you think? Will this repeat in your case? Or?
So it's a very interesting question, and also this practice by SpaceX is called vertical integration, where they build everything in house, and I feel there is no other way to actually cut costs for a US company. That is the only way, because the contracting, dealing with the vendors, their costs is only going to build $1 billion rocket. You can never build a rocket with a NASA contractor ecosystem there out of US. That's what openly told by SpaceX also, and they've done a really, really great job in bringing the cost down. Main reason is because of vertical integration. They build, manufacture, test everything on their own. That's the ideal way of cutting down the costs. But however, this would increase the infrastructure cost to a lot. So if you have really the money to actually build the infrastructure, better only do vertical integration, because that affects the cost a lot. So but when it comes to us in Skyroot, so our philosophy has been totally opposite to it. So we don't go for vertical integration. We outsource everything. So that model is only feasible in India, I would say. It's because of the really great ecosystem which happens with all the vendors built by ISRO, etc. And if you actually build all the infrastructure to build the rocket, it is going to cost a bomb. So it's not worth the effort and money to actually build the infrastructure for actually building a rocket. For us, the best way is to actually use the infrastructure available, because it's overall, even if you use it, the costs are low. That's the advantage here. But when it comes to US company, they actually have to struggle a lot to create the infrastructure. That is another advantage which an Indian company would have, like Skyroot, which we are actually very happy about, is that we can actually go quickly to the market using the infrastructure rightly available already in the country, and we are also designing to their sizing. That is one advantage. So that we need not create, building infrastructure takes a lot of time and money and effort. All that effort we are putting in designing the rocket and getting things done at the right time. Right? So, but when it comes to bigger rockets, I feel in India also, the best approach would be vertical integration. Where you cannot give the tank to one person, the engine to one person, the components to one person, the pump to some other person. It's gets very, very difficult and cost prohibitive when you go to bigger rockets in this competitive landscape in the world. So eventually, as we go bigger down the line, so we plan to have a vertical integration kind of a setup for building larger rockets down the line. And upfront, as I would say, vertical integration is the best procedure for building rockets to cut the cost. But only if you have deep pockets to actually get the infrastructure done. And in US, there is no other choice. So in India, you have a choice. You have to choose the right different size of the launch vehicle, depending on what you're doing, etc., etc. But as I told, we chose the thing which is opposite, which works for us best.
When SSLV is going to be launched, and assuming ISRO's record it is successful, there may be a plan to actually transition the SSLV to the private industry.
Yeah.
Do you foresee a lot of challenges for the ISRO vendors to take up that level of activity, because they have never been involved in that level of activity ever before?
Yeah. So I would say if they're actually outsourcing SSLV, the ideal way to do is to independently launch, full from producing to launching to managing mission. If it's totally outsourced, then currently I don't think anybody is capable except companies like us, like Skyroot, which we are actually building the capabilities. But I'm pretty sure that is not going to be the way in which they're going to outsource. So it will be something similar to PSLV what they have done. So what will happen is that the entire supply chain will be handled by the private sector, similar to what PSLV has been rolled out recently with that EOI. I would foresee it to be in that way rather than entirely being rolled out. So when it comes to handling that, definitely the same EOI people like who are handling the PSLV would be able to do it, because the SSLV is much, you can say, like much smaller version of the PSLV, so they can easily handle that. But I'm to at least my understanding of ISRO and like SSLV, they're definitely not going to outsource the entire SSLV to private sector. Even if they do, I don't think like only Skyroot and companies like us only would be able to handle the entire mission aspects of it, launch operations, etc., etc. But I feel they will not be outsourcing those portions of it. That will be kept to ISRO or maybe Antics or NSIL. And the supply chain definitely will be outsourced to private industry, and that can be easily handled by the same supply chain which produces the PSL.
Were there any aspects of technology or services also, let's say mission control software or any other services aspects of it that you foresee licensing from ISRO?
Yeah, definitely. In fact, we would like to, given a chance, we would like to utilize as many facilities ISRO is having to provide to us, and I believe they should, So, I personally feel that when there is an infrastructure in the government and there's excess capacity, it should be given to the private sector to be utilized. And there's a market out there to be captured. After all, it's 4x for India, right? That is one thing. So, I foresee that like if all the launch licensing and everything is done, we hope to utilize their mission facilities also, and the radar facilities also. It all depends on how things roll out down the line, how the mindsets of the people change, how the policy turns out. So that all is going to be a good amount of drama which is going to happen in the next 2 years to see how the private companies are going to come up and how the mindset of the government agencies and the policymakers are going to change in the next 2 years, especially on the launch industry, is going to shape up, is to be seen now. It's not fully clear as of now, but given a chance, we would want to utilize as many facilities as possible and keep our infrastructure to as low as possible.
Apart from the launch vehicle scene, how do you see the other new space players in India, and what is your vision for them, or how do you see the ecosystem maturing in India?
So one really good interesting thing which I found is satellite constellation startups, the people building constellation of satellites aiming to be like, when it comes to Kava Space and Pixel coming down the line. It's very interesting to see what they're doing. And wish them all success. And I hope to see like more companies like that building the local infrastructure for building satellites. And also like I wish the government also like recognizes it and also like utilizes their capabilities, or also like help them expand, give their resources, multiple things down the line. So that way, like it's very exciting what is happening last 2 years in satellite. The new companies coming up, really good, and hope to see like many more companies like that coming up down the line, and also do very, very interesting things, much more interesting things than what is happening right now.
Let's talk about the future scenario of how the launch vehicle industry is going to pan out globally a little bit. So we talked actually about the current operational landscape with Electron and few other rocket companies being mature or coming into the fold. Let's say 10 years down the line, what do you see as a scenario, including you being in that scenario, the landscape would be?
So 10 years down the line is very difficult to predict, especially when it comes to small size space industry and launch industry. But I could say in the next 5 years, as I mentioned before also, like I think like there will be like 10 players who will be doing their services, and the market per se at that point of time I cannot comment on. It could be really much greener than what we expect, or it could be a little bit more dull than what we expect, and we could sometimes we could also see the rideshare services eating onto the market of small launchers also down the line. So that is very difficult to comment, but I see that but one difficult aspect is actually ramping up the launches for any company. Even if 10 people come into operation, all together may not be launching so much even after 5 years, right? That is the reality. Whatever you say, even if a company says I'll be launching one per week, it's very, very difficult to go to that level of mass production. That level of launch frequency is a little bit difficult. And the earlier the company goes, the much bigger chance it goes to. And hopefully we see as many small launchers who are coming up. I think there's good space to coexist for them. And 10 years down the line, what would happen? I feel that a successful small launcher would not remain with small launchers. They would definitely upgrade to big launchers and down the line, because that is the immediate good next step to go ahead. And also like diversify to other fields in upcoming fields in space also that way. So I feel like small satellite launch per se after 10 years when it comes to launch vehicles, very difficult to predict. But there will be some good players, I would say, who would be diversifying to other fields.
There are a number of new interesting players within the small satellite market, especially in terms of putting the payloads to their intended orbits from a bigger launch vehicle. So there is this company in the US called Momentus, for example, right? So they have recently, worked with a number of companies, number of launch vehicles as well, that they have then partnered, saying that they will essentially have their payload interface with a rocket, which then will host a number of satellites, which can then be put into orbit by them. So it is almost as if they're offering what I call as a orbit as a service model.
Yes.
And so essentially, I think now they have a few launch vehicles that they're interfacing with.
Yes.
So do you see a threat from this kind of community?
Yeah. So thing is that always rideshare market would be there and would keep on evolving. So what you were saying is that in a little bit next level of evolvement of a rideshare business, that will definitely be there, and that is definitely even more cost effective, no doubt about it. And the only thing is that down the line it can actually eat away some market of specifically small satellite launch vehicle. But still, like when the market is big enough, right, different players choose depending on for some players cost is not an issue. For some players, actually reaching the right orbit in the right time is an issue. For many people in the rocket industry, availability is the issue, right? So, depending on the customers per se at that point of time, when the large market is big enough, always there will be efforts to actually reduce the cost. And one way of reducing the cost is what Momentus is doing, the extra service, where different satellites can go to different orbits, different altitudes from the same mission, using ride sharing on a bigger rocket, which is cheaper, right? So, very interesting ideas will come up down the line, and also, but I think it should evolve. Finally, it's the customer point of view who should win, right? So, ride sharing on bigger rockets, and also like extra in-orbit servicing, applications also with turnoff will keep on growing down the line. And also like the small satellite launchers also should evolve. They also will, as I tell, the cost will even come down. Their services, niche services will increase. They may provide a little bit more amount of services, like the upper stage could be like a satellite. There will be all industries will evolve, and also like market also keeps expanding with time. So we have to keep evolving with time and also. But for your question whether it will be a threat, I don't think it will be a major threat. It will only be like one more additional option available for the customer to choose from, depending on his constraints. For him, some customers may not choose that, but many customers may choose it, depending on it. But as I told, they will also keep evolving, and the small launch industry also keeps evolving with their own new applications, getting new different types of customers. This also, rideshare market also will get its own customers. It also keeps evolving. So I don't see it as a major threat per se. Yeah.
For a company like yours, when do you start with business development? Because technology development is itself such a long step.
Yeah. So it's a parallel process, and also like right now our focus is less on business development, more on technology development. And so once we get things further, down the line, we want to increase good amount of focus into business development, where like we actually talk to good amount of potential customers and see their problems, and also like modify our slide designs also based on their requirements. That all will come down the line parallelly. So, but right now our focus mainly is less on business development, more on technology development. But as we go further in the next 6 months to 1.5 years, 2 years, we will shift the focus to good amount of business development down the line.
Leaving a government sector job is actually extremely difficult for anybody who comes from traditional Indian background family.
Yes.
How supportive your and Bharath's, your co-founder Bharath's families, your spouses and your family, and how difficult was it for you for making this leap?
Yeah. So first thing is like what you said is absolutely right. It's very difficult for Indian parents to actually absorb such a thing. But naturally, same thing we faced also. So, but the thing is, the decision is finally ours. So I took the call that I'm going to quit and start the company. But my parents were not so supportive initially, of course, because ISRO is a very prestigious job, and doing well there, and also continuing there was really good option for them to, and also they don't want their child to stress so much. They think entrepreneurship is so much of stress, and also like it's like coming back to zero and working so hard again when you actually work through college and got a nice job and just settled, right? So it was very difficult for our parents to absorb, definitely, and I know this, in the initial phase itself, I know this, and it's basically finally a call from our side that we are ready to take this challenge. And also like for me, it's like more adventurous to be a space startup. I personally feel as an individual, I can give more to the space industry than being part of ISRO. Being there for 40 years, and also coming out and being there for 40 years, there's a significant difference, no doubt about it, especially when the space sector is evolving. And because I'm very, very sure that public-private partnership is the future of space industry, government space industry in India. I'm very, 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 very clear on it. And also like someone should start, some brave attempt should be there for the industries to go on. And the same thing even with Bharath also, like their family also was a little bit skeptical on this, but still like now they are a little bit more got used to it, and also like a little bit more supportive right now. But initially it's a tough call for them, but for us it was like a little bit more of an easier call, because like we understand the opportunities, and also like being a space enthusiast myself, like so I am very, very clear that my contributions would be easier outside and much more wider outside than within a government agency. So we're one part of a big game. When everything is fixed, next 5 years, what to be done is already very clearly outlined out. That's not something which someone who is very ambitious or someone who is very, very interested in actually evolving the space sector would want to have, but still it has its own benefits and etc. So it's finally a call. It's a very tough call, I would say, but it's a happy now as of now. We're very happy to actually start this and moving ahead, and let's see how it turns out. Yeah.
So I wish everyone at Skyroot, you and your colleagues, very good luck with all that you are building. I think you are doing a fascinating job of not just trying to, take this leap of faith but also inspiring hundreds and thousands of other young people in India to take up space entrepreneurship. So I consider you guys really as the role models leading the pack among all of them. I wish everyone the best of luck, and hopefully we will do follow-up episode as you move along.
Yeah. Thanks a lot. And also good to see this initiative, it has to expand, more people in space industry also should come and share their views. So hopefully we'll talk again once as we go further. Thank you.
Thank you for staying until the end. If you have any comments or suggestions, please write to curator@newspaceindia.com. Please consider sharing this episode with any friends or family who may be interested in learning about India's space activities. If you would like to stay in touch with the NewSpace India community, please use the link in the description to join the NewSpace India Telegram group. Feel free to also suggest guests for any future episodes. A new episode of the NewSpace India podcast is released every other Friday. Do subscribe to the podcast using Apple, Google, or any other podcasting platforms you may use. Thank you.